Hi, this is stage 1 of solving simultaneous equations using the elimination method. The first thing we're going to need is a pair of simultaneous equations, and here they are. Now, these are simultaneous equations because they are simultaneously right at the same time. We have some x's and we have some y's in the first one, and we have some x's and y's in the second one. And if we solve them and find the value of x, it will actually be the same value for both equations. And if we find the value of y, it will be the same value of y for both equations as well. And they will both be true for those values of x and y. Now, usually, if we're solving an equation, we just have one equation. But because we have the two variables, x and y, we need to have two equations to be able to solve them. Now, I think a really good way of visualizing what this means, these equations actually mean, is to use the bar method. And here's a bar representation of our two methods. Our two equations, sorry. So at the top there, we have 5x's and a y. And so we have 5x's in a row and a y, and they equal 15. So the 15 is the same size as the 5x's and the y. And at the bottom one, we have 2x's and a y. At the top, we have 2x's and y there. And they're equal to 6. So they are the same size as 6. Remember, equals just means the same as. So 5x plus y is the same as 15. 2x plus y is the same as 6. Okay, so where are we going to start with this? Now, if you're from my class and you're watching this, you should have a copy of the flowchart which I've produced, which shows you a nice simple kind of method of how to get to the end and solve simultaneous equations. If you haven't, I'll put a little flash of it at the end of this video so you can see what we're talking about there. And if you follow the steps, it should be fairly straightforward to solve these. Now, the first thing I always say with simultaneous equations, whether they're really tough ones or whether really easy ones, is to number them, to label them. So I'm going to call that equation 1. And I'm going to call that equation 2 in case I need to refer to them. Now, the first thing to do is to look at, according to our flowchart, it says, does either variable have the same quantity? And by that, I mean, do we have the same amount of either x's or same quantity of x's in each one, or the same quantity of y's? Now, this one, we can see we've got 5 x's and 2 x's, so they're not the same, but we have one y and another one y. Remember, this y is really just one y, but we just don't bother writing the 1. So yes, they do, right, which means we can move down the flowchart. And we want to find out, firstly, are they both positive or are they both negative? Or are they different signs, the two y's that are the same? So they're both positive, which means we're going to take one equation away from the other. So actually, straightforward, I'm going to put a line underneath and take one equation away from the other. But before I actually do that, let's look at what I mean. Over here, I've actually got 2 x's and a y on the bottom equation, and 2 x's and a y on the top. So I could just chop off this whole end section and leave these 3 x's at this end on their own. Now, to do that, I'm also going to have to chop off that 15. I'm going to have to cut it in half. Now, I know if I cross through the 15, this end bit of this bar must be worth 6 because it's the same size as the one below. It's the width of 2 x's and a y. Now, this whole bar I know at the top here is 15. So how much more do I need up here? Well, I need 9. That must be 9 because the 9 and the 6 makes 15. Now I've actually got the same width on there, I can actually cancel them out. I can cross them out. So we don't need any of those x's, we don't need any of those y's, and what I'm left with is 3x is the same as 9. Now let's see how that matches the algebra. So over to this side, I've got 5x, and I want to take away the bottom equation from it. So I can do this in columns. So I do my 5x, take away my 2x, leaves a total of 3x. I've got a y here, and I'm going to take away a y. Well, y take away y leaves nothing. I'll put in my equal sign, which of course means the same as, and I've got 15, take away 6, leaves 9. So I've actually got 3x equals 9, the same as my picture over here. 3x's is the same as 9. Next step then is to look down my flowchart. I've taken one away from the other, one equation away from the other. It says solve this new equation to find the value of one variable. Well, if we've got 3x equals 9, I think we should generally know by now, if I want to find the value of 1x, I need to do the opposite operation, the inverse operation. So I'm going to divide both sides by 3. 3x divided by 3 is just x. And 9 divided by the 3 is 3. So x has the value of 3. Now back to our picture. Let's look over here. Does this agree? Yes, it does agree. Look, we've got 3 x's and it's worth 9. Well, we can see on here that we need to share the 9 between the x's. The x's are all worth the same amount. So we need to share the 9 between the x's. So we're dividing by 3. Okay, that's fine. How about, though, what's going to happen next? Well, down here, here's a representation of what I'm going to do on my next stage. So on my flowchart, it now says substitute the variable for its value. So that value I've just found, the x is 3, I'm going to swap my x's for that 3. Now I'm going to go back to one of my original equations, and I've chosen to do the second one, the 2x plus y equals 6, because it's nice and simple. And so instead of having x here, I've now got 3. So let's have a look. What have we got? We've got 3 and 3, which of course makes 6, and I've got a y. Now I'm going to cut off here, and I'm going to see what value y must have. Well, these two 3's are the same as 6, which is actually what I've already got. But I need to make a total of 6, so the only thing I can add to y to make that work will of course be 0. So actually in this case, y doesn't have a value, it's just 0. So there's my two answers. X must be equal to 3, y must be equal to 0. But the algebra, what algebra did I do here? Well, I took my equation, my 2x plus y equals 6, and I swapped my x for the value of x, which is 3. So 2 times by 3 plus y equals 6. And I can see that this bit must be 6, 2 times 3 is 6, plus something equals 6. Well, I don't need to add anything to 6 to make 6, so x must be 0. So that's the algebra we did there. So on to example 2. First of all, we're going to need another pair of equations. So here we are. Now we've got 2x plus 3y equals 19, and 2x plus y equals 9. Remember, the equals just means the same as, so 2x plus 3y is the same as 19, and 2x plus y is the same as 9. Now, I like to see this in the bar representation, so here we go. We've got 2 x's and 3 y's is the same as 19, it's the same width, and 2 x's and a single y is the same as 9. So what am I going to do? I'm going to look at my flowchart. My flowchart says, does either variable have the same quantity? Well, yes. There's 2x on this one and 2x on this one. The y's are different because it's 3y and 1y, but the x's are the same. Now I want to know, do they have the same sign? Are they both positive or both negative? They're clearly both positive. So yes, they do have the same sign. So I need to take one equation away from the other. Now, what does that kind of mean over on this side? Let's have a look. When I'm going to take this bottom block away from the top block, so the second equation away from the first one, which of course I should have labelled, that was the first thing on my flowchart, which I didn't do, so let's go back and do that, 1 and 2. Over here, I'm going to cut it off at the same width, so there, I'm going to take all of that and all of that away and make it disappear. Now I know, if I cross through that 19, I know that this side is worth 9, so this side must be worth 10, because 10 and 9 will make up 19. And that's fine, I'm going to take them away then. So I'm going to take away that x, and that x, and that x, and that x, and get rid of that 9, and the y, and that y there, and the 9, and I'm left with 2 y's and a 10. Let's see how that matches the algebra. So I've got 2x take away 2x, well, that will leave nothing. I've got 3y, and I'm going to take away a y from it, and that's going to leave just 2y. And then I've got 19, take away the 9, will leave 10. Next part of my flowchart says solve to find the value of your variable. Now my variable is y. I've got 2 y's here, and they're the same as 10. So I don't want 2y, I just want the 1. So I'm going to divide by 2 to find out the value of one of the y's. 2y divided by 2 just leaves y. 10 divided by 2 is 5. That makes sense, doesn't it? 2 times 5 is 10. So that's the value of y. Remember, that value will be the same for both equations. Now the second part of my flowchart, or the latter part of my flowchart, then says substitute that value of y into your equation. So I've done that here. I've written out my bars, and I've changed y for the value 5. Now I want to find out how much the x is worth, so I'm going to cut off that 5 off the end, but that means I've got to cut this bottom bar. Now I know that end bit will be worth 5, so this part must be 9 take away 5, which is of course 4. So I've got the two x's are worth 4. Now what was my algebra then? Also, I'm going to cut that off the end. I had 2x and a 5 is equal to 9. And then I cut the 5 off. I took the 5 away. So I took the 5 away, and I took it from the top and the bottom, so that's both sides of my equation, and I was left with just the 2x, because 5 take away 5 is nothing, and 9 take away 5 is 4. And again, I need to then solve to find the value of 1x. Well, if 2x's are 4, if I divide it by 2, I find that the equation must be worth, the x must be worth 2. So x equals 2 and y equals 5. Okay. Now try the questions if you've got the questions for homework.